Hi everyone, I welcome you to this presentation on compound generators. So compound generators, we've got two types. By definition, a compound generator is basically a generator which contains both the series and the shunt winding in the same machine. So we have two types of compound generators. These are what we call the short shunt generator as well as the long shunt generator. We're going to start with the short shunt generator. So a short shunt generator, the circuit looks like this one shown here. You have the armature there, then you've got the series field connected in series with the load, and then you have the shunt field winding which is connected parallel to the armature like that. So this is a short shunt generator. From this one we can derive some formulas. We know that this armature current, this one here, as it comes from the armature, it splits. There is the current going through the shunt, which is the shunt current, and the one going through the series winding, which is the series current. Therefore, the armature current is the summation of these two, shunt current and the series current. So we derive this formula, and then we know that terminal voltage, as I explained, when you're finding the terminal voltage, you get rid of the shunt. So when you get rid of the shunt, you realize that terminal voltage is supposed to be the voltage on the shunt and the voltage on the series winding there, but the voltage on the shunt is in parallel with that one, so just that one there, and then the one on the series, the current there is going the other way, it's not going on the voltage, therefore the one on the series is made to be negative. So you are going to have that as your formula for the voltage. Then you have the generated EMF. Generated EMF, as I said, you get rid of the shunt winding. When you get rid of the shunt winding, you just add the summation of all the voltages. So generated EMF will be the terminal voltage plus the voltage on the armature and the voltage on the series winding. So you're going to come up with this. I highly recommend, if you haven't watched the introduction to DC machines, please watch that, and then you understand how I'm deriving this. Then we have got the power delivered to the load. Power delivered to the load is basically the voltage on the load and the current passing through the load, which is this one. And the last type of power is the generated power. Generated power is the generated EMF and the current itself, armature current. So you have this. Those are the formulas. So from this one, we're going to look at an example. So the question is saying, a short shunt compound generator supplies 80 amps at 200 volts. If the shunt field is 40 ohms, the series field resistance is 0.02 and the armature resistance is 0.04. Determine the generated EMF. So the generated EMF, we just analyze the data. This is what we've been given. We know from this one, the load current and the series current are the same, which is basically 80 amps from the question. Terminal voltage is 200 volts. Shunt resistor is 40 ohms, series resistor is 0.02, armature resistance is 0.04 ohms. So from this one, we can easily calculate the generated EMF. But before we do that, we need to find the armature current. Armature current is basically the summation of shunt and the load. If you make shunt current the subject from one of the equations I gave you there, you're going to have the formula for shunt current, which is this one. When you do your substitutions, you're going to have 5.04 amps as the current passing through the shunt. Armature current is basically that. When you put those in there, you're going to have that as your armature current. With that, it's easy to find the generated voltage because you have all the parameters. You have the load voltage and all those. When you substitute, you're going to have 205 volts as the generated EMF. On the next slide, we're going to look at the long shunt generator. So a long shunt generator looks like this now. For this one, the series winding is in series with the armature, and then that is in parallel with the shunt field winding. So from this one, you realize that the armature current and the series current, they are the same, and these are producing the load current and the shunt current. So from this one, we can derive those formulas. So we know that armature current is basically that, shunt current, which is just the voltage. So voltage is basically, you're getting rid of this, you're just going to have this one and this one in parallel. So this is producing that. Then generated EMF is that. Power output will basically give us that. Then the power generated is basically generated EMF and the current on the armature, which is that. This marks the end of my presentation.